All right, so we are going to introduce Coulomb's law in this video. This is a fundamental law that we are going to be using quite frequently, but let's first remind ourselves what the electric field due to a point charge is. An electric field due to a point charge is governed by this equation here, k q source over r squared times r hat. So if you have some source charge, it's producing an electric field that looks something like this. And we know that if you put a test charge in that field, the force that that test charge is going to be experiencing is given by q test times that electric field. So now I'm taking that electric field, I'm plugging it right into the equation there for the electric force, and I get this equation called Coulomb's law, which tells us that the electric force on a test charge is equal to k times q test times q source divided by r squared times r hat. This is only valid for point sources or spherically symmetric charges, which we may see in the future, so watch out for that. I'm just going to move this up to the top really quick, and now let's look at the how this equation works and break it down a little bit with a picture. So let's say that I have some source charge here, and let's say that the source charge is positive. So I'm going to represent my source charge using a circle with a plus in it, and I'm going to label this as Q and then source, subsource. So there's my test charge there, my source charge there, Q source. Now let's say that I put a test charge over here. I want to know, how does this charge experience the electric field from this source charge? What happens to this charge here? Let's say it's also positive, and I'm going to label this as Q sub test. So there's my test charge. I put this test charge in the electric field here. Now Coulomb's law is telling me that the force that this test charge is experiencing is coming from the electric field from this source charge. The electric field from this source charge I can determine by labeling, there's my R value, the distance between the source charge and the test charge. And at this location, my electric field is going to be pointing radially away from the source charge since this charge is positive. So at this location, my electric field might look something like this. So here is my electric field by the source charge at that location, R. Then Coulomb's law is telling me all I need to do is take this electric field and multiply it by this Q test in order to understand what the electric force is on this test charge. So now, since this charge is also positive, the electric force is in the same direction as the electric field. We don't have any introduction of any negative signs, so my force is in the same direction as the electric field, and I might draw it look something like this. F, my electric force on my test charge by the source. That's sub ts here, on the test charge by the source. Now I can also think about what's happening with the source charge, because this source charge is also experiencing an electric field from the test charge as well. So what happens is this force, electric force, is a third law pair with an electric force that is also the electric force on the source charge by the test charge, right? So there's our third law pair of these two forces interacting with each other. And now we can sort of start to see why we say like charges repel. We have two positive charges here, and they both are experiencing a force that is away from the other one. So these positive charges want to get away from each other. Now in contrast, I could think about, here's another Q source. Let's leave this one as positive. And now if I want to think about, maybe I have a negatively charged test charge out here. So at this location, here's still my radial distance r away from the source charge. At this new location, my electric field hasn't really changed, right? My electric field is still pointing, my electric field from the source charge is still pointing radially away from the source charge here. So I can still draw an electric field by the source charge at that location r. But now, because my test charge is negative, my force is in the opposite direction of the electric field. So I might draw a vector that looks like this. Here's my electric field on the test charge by the source charge. And then we know that the opposite is also true for the source charge, where this Q test is producing an electric field that's pointing radially inwards. And so now this source charge is going to be pointing in that direction there. Here's my electric field on the source charge by the test charge. And so there's our third law pair. So now we can see why we say like charges repel and opposite charges attract. These two charges want to come closer together, which we can see from Coulomb's law, and then these two particles want to move away from each other.